My name is Madhav Somani. I think Kevin already introduced me. Love to see you guys. And we gave this lecture last year too, and super fun. So my point over here is we will go through a journey together. In the next 45 minutes, my job is to make sure AI is magic to I know AI. This is where we're gonna be. Rather than AI is magic, we'll make sure we learn everything that AI has to offer to us. And then I'll make you through from 1940s when the AI was coined, the term was coined, to neural networks, to perceptron, to how you can build your own AI, how you can build a multi-million-dollar company, to everything that AI has to hold. So we'll go through the whole journey together, right? Anyone who, okay, let's start with this. Let's start with a quick exercise. Who has used AI? Just raise your hands. Okay, one, two. I think everyone. Have you? Perfect, perfect. What is the most, what's the best AI product you have used so far, which you really love? Anything? Gemini, ChatGPT. What makes you like copy Kevin's homework easily? He doesn't have to listen. We'll make him give us A-grades things. So I personally, when me and Kevin, when we are working together, I love ChatGPT. Has anyone of you guys used it? Any other product you have used besides ChatGPT? Claude, pretty nice. Gemini. Copilot. I wrote some modules for Copilot. It's pretty fun. Anything besides this? Okay, so I think these are like the topmost. So you guys are already caught up to the industry. So we'll start with products you've never heard about, which were like the babies of like recent Geminis and ChatGPT. Now, today's journey, 45-minute interactive session. We'll do real world exercise, we'll do basic concept to practical endpoints. We'll learn about perceptrons, AI, neural networks, all that funny stuff. Now, when was AI invented? Well, technically, AI was never invented. It was a thought of our favorite, John McCurdy. At the conference, John McCurdy in 1956 was like, hey, I feel the machines should just think. That's where the first artificial intelligence, the word was coined. In 1956, that's like 80 years back. That's how far it is. The goal was let machine things that could reason and learn and solve problems. Well, he said it very easily, but no one knew like how to get this thing done. They were like, hey, do you see this chess? I want machines to beat us in chess. And then everyone was like, John McCurdy, are you crazy? That's no way. Because at that time, the computers were like in their typos. They could barely do like 1+1. And this guy wanted machines to figure out a way to like beat us in chess, right? So Bobby Fischer, like everyone was like, there's no way. There's no way Bobby's the king, no one can defeat him. But that's where the thought came from. Machines should be able to beat us. And key pioneers, Alan Turing, was also the one who invented this thought process that, okay, if machines can think, how do you differentiate between machines and humans? That's where the Turing test came from. To figure out if machines can think, can it really fool a human? And that was all happening in 1950s to 80s, where people were trying to figure out this concept of artificial intelligence. Now, what is AI? Madhav, I love the term AI. Everyone keep talking about it. What is AI? In basic terms, this is AI. It's just neural networks stitched up together with multiple nodes. Now, think like this. Does anyone know what neurons are? You? Go for it. Give me like one line just.
Oh, I thought you. No, I don't really explain it.
Just give your basic understanding. What do you think the neurons are? In your brains, everyone brains have like neurons. They work together, right? And you can correct me if I'm wrong here, okay? So neurons are like this simple binary 1 and 0. They're like this. If neuron sad, they do not pass electricity. They're like, oh, sad. If neuron happy, they're like, electricity, go. That's what neurons does in your brains. And if you combine all these neurons together, they form humans. They form me, Kevin, they form us, right? These are what neurons are. And engineers were like, okay, I see brain. Brain knows this is ice cream. Machine doesn't know it's ice cream. How to make machine say it's ice cream? Okay, what brains does? Neurons collected together says ice cream. That's what they thought. Let's just use the brain, make it into a mathematical function, and then give it to machines. Then the machine could be like ice cream. That's the thought process, right? Funny, but at that time, no one knew how to make that happen. So engineers came together. They were like, okay, let's see what neurons are, right? And let's see if we can replicate it in machine language. So far, everyone is with me, right? Okay. Okay. Now, this is the most mathematical equation I'm going to teach you guys. After this, we're not touching this maths ever again, right? But this is like one understanding I want you guys to have before we move forward, right? So what they did is they wrote this function. They were like, hey, z is equals to x into w plus x2 into w2, and everyone was like, okay, this can solve a neural network equations. So this is the reason machine says ice cream. Now I'll explain it to you in like the simplest terms. Now this is generalizing a lot, but this does give you like an idea how machine thinks, right? So you take x1, x2, right? These are nothing but your input layer. Z is your hidden layer, and then Y is your output layer. And they thought like, okay, what if I give an input, right? And then whatever the input is, you multiply it by W. W is nothing but how strong you feel, right? Just like how neurons were like, hey, neuron, do you want to pass this electricity? I feel sad, I don't want to do it. So your W becomes like 0. And if your neuron is like, hey, I feel 80% happy today, I'm going to let this electricity go, right? And it just raises his hands. So W could be like 0.8, 1, anything. So you multiply these two vectors, and that brings you to Z. And Z would be accumulative of everything of input layer connected to this particular node. In the end, Z becomes x1, w1 plus x2, w2. And then Y is nothing but your output layer. Y job is to say, hey, is when the Z comes to me, if the Z say 0.2, I have a written instruction. It says if Z or whatever the input I get, whatever the Y input gets, if it is less than 0.5, it means no. If it's greater than 0.5, it means yes. It's a very simple instruction, right? So whatever Z gives it, Y just translates it from numbers to text. So if it's less than 0.5, Y says no. If it's greater than 0.5, Y says yes. That's it. This is the holy grail of how NLM, ice cream, everything works. This is where the magic happens. But it was so much mumbo jumbo, I'm sure I lost few of you guys. So we're gonna do some practical example, right? I'm gonna make you an LLM model. I'm gonna make a neural network right here in this class, right? This is what we do. We have an input layer, we have a hidden layer, and then we have an output layer. Neural network works like this. You pass the image of a dog in the input, it travels through your hidden layer where the processing happens, it multiplies like weights and like numbers and gets to output, and the output probability would say dog 98%. So you pass an image of a dog, but the neural network figured out text, it is a dog. So it can predict any image. You pass it the image of this animal, in the output layer it will show you cat, right? So let's make this right here. So you guys understand what neural networks are, and then we'll scale it up, right? We'll start with the lowest. We'll start with the lowest numbers, and we'll scale it up, right? So I want 3 volunteers, right? And in this exercise, if you guys, my output layer was.
We may have to switch to 2 volunteers because I'm not sure if our input layer is big enough.
Is it?
I'll be a part of the input layer.
Yeah, you be a part of the input layer. Perfect. Okay, I need 2 more volunteers. And at the end of this exercise, I will get you guys A grade if you guys can solve this equation, right? If you win in this exercise, Kevin will get you A grade.
Yeah.
So I need 2 more volunteers here. Okay, come on in. Kevin, I need you too.
All right, I'll be an input layer.
But you could like bias the exam. Go back.
No, I can buy the.
Yeah. I need 2 more. You become the output layer. All right, come on in. I need 1 more. Can anyone come in? It's A grade, guys. Come on.
Front row. Go.
Want to come in? Yeah. All right. All your job is going to be just raising your hand. All right. So I'm going to train you guys first. Let me get my phone. Okay, perfect. All the model sizes just happened. But the that thing happened only because they had more time. ChatGPT was racing towards building up the bigger model and the fastest model. Once you have that model, you can use these models to train smaller models. Now you have an LLM which can figure out an answer. You already know if you give an image of a cat, the LLM model tells you it's a cat. Now use that into an API, and now when you're training a model, a smaller model, it's known as supervised learning. You replace the person from the bigger LLM model and ask the LLM models like, hey, your job is to build up a smaller model, right? So you pass the information to the smaller model and then make sure it doesn't go above 500 billion parameters. And the result is the 450 billion parameter llama model is as good as ChatGPT. So what we learned today is that scaling can happen if you just improve the quality of the data. If you just improve really good quality data, you can train a model as good as a trillion parameter model just by reducing the size of neurons. And it's little technical, but it's also known as overfitting. You know what overfitting is? When a model is like it just fits a pattern. It doesn't understand that concept. It just like mug up stuff.
I talked about overfitting in our last lecture when I was talking about decision trees.
Oh, perfect. Overfitting is the reason we have a trillion parameter in ChatGPT because sometimes they overfit, but they don't know where they overfit because it's a black box. So you can't like just chunk out the those parameters, right? So you once sometimes you overfit, sometimes you don't, and that's why you have a trillion parameter. But when you are really conscious about not overfitting, that's why you have llama. 450 billion, not too much overfitted to the values, and you still get good values out. Did I able to answer your question? Perfect. Now, what is AI hallucination? Now, this is where the interesting stuff happens because this is more related to databases. Yeah, go for it.
Just going off of the last part. So you mentioned that having like a ton of resources or more like compute power, things like that, that'll reduce bias. But if you don't have like any of those resources and we're making like models like in school or research, how can you ensure that there's no bias when you're not training it on millions of pieces of data?
That's a great point. Honestly, that's a challenge every single scientist goes through. Every single engineer is trying to figure out with limited resource, how can you figure out if the AI doesn't have too much bias? So what they do is again, this is also a holistic approach. It doesn't work all the time. I've seen it doesn't work in Amazon. I've seen it doesn't work in Microsoft. I've seen it a lot of places. But what they do is they already take an input data set, right? And they say that okay, I already know the answer of this. So they give you a cat image, and they already know that this image is of a cat, and they pass it through the model and see is it saying the right thing, right? So that's how they know it is working correctly. And they try to inject by also take like data which is non-biased. For example, like hey, can you create an image of a guy using his left hand to write? So they now take those biases, which they have already found out, into the original data set of calculating if the model is successful or not. So if it's not passing this, the model doesn't even see the line. So now they've started adding this. But again, that's the question. What if there is a bias which we don't even know? That's where it happens where people just like put it out there and then folks outside tells you that okay, I found this new bias. This left hand bias came from people, not from the original engineering team. So we can do is like calculate the best thing, but it's always anonymous. These things always appear sometimes from thin air. So it's harder to like detect. But what we can do is always like try to scale up, have a richer data set, try to remove as many biases as you can during the foundation model training so it doesn't affect you in the end. Now, hallucinations. Do you know what hallucinations are? Anyone? Want to make a guess? Go for it.
It's just making stuff up because it has to say something.
Dude, 100%. It just makes stuff up. Has anyone seen this behavior when you guys are like using ChatGPT? You've seen it too? Nice, nice. Has any of you guys seen where ChatGPT just like makes up stuff? You too? Nice. Everyone has suffered through hallucinations. Now I'll teach you. Madhav can help you out with this. I can help you guys understand how you can beat this thing. And there are better ways to beat this than biases because we have found a perfect way to beat hallucinations. It's not 100% guaranteed, but it does keep your data way grounded than original data set. Now I'll show you. Um, The first time I figured out AI hallucination was this. I think last year I was writing a research paper. I was writing a research paper on restaurant gamification. So I have bachelor's and master's in software engineering databases. I did my master's in advanced databases and AI, and I was writing this research paper, restaurant gamification. And I asked ChatGPT, "Hey, can you write this paper for me?" And it just rich 10,000 page lovely research paper it just wrote, and I was so happy with it. It was amazing text, amazing simulation and graphs and everything. But then I went to the end of the research paper, and it said uh, 10 citations, right? And one of them was Gibran from University of Africa, also referred to my paper this particular morning, and I was like, wait, what? Like, this has already been discussed in Africa. How did I not know about it? So I Googled it, and that University of Africa or that Gibran doesn't exist. It just cited some Dr. Gibran for me so that it can make me happy. Because in my original prompt I said, write a research paper with 10 citation on this topic. It only found 9. So the 10th one was just hallucinated, because we taught the LLM models to give us the best results. So now the output layer is always like, hey, I need the best results. So the input layer is like, okay, I'll make up stuff for you so that you can fit your criteria. And that's what happened. That's where the hallucination comes from. How can we fix it? How can we fix this information? Especially like if you use AI for like medical advice, legal information, you need to fix hallucination. Have you been to like Google and be like, hey, my head hurts, and the Google is like, you have cancer. Like, bro, I just had like just give me ibuprofen. Why do I have cancer? That's happened when you have like when you're injecting AI in like medical advices and legal information, it can really hallucinate information. So the holy grail of fixing stuff, RAG. Does anyone know what RAG is? Anyone heard about it? Kevin, you know it. Oh, you know it too? Nice. Give me like one line. What do you think RAG is?
I did an internship on that. It's like when you give some context to a model so it can retrieve information faster. For example, you give it some documents so you can get the context from them when you ask it something.
Dude, A grade for you. That is absolutely correct. So what he said was, you remember you have like input layer, right? I had like 3 people over here raising their hands. Now I said, there is a trillion of these people raising their hands. But, for example, you only said the sun distance from moon, or like moon distance from Earth or something like that. That only takes like 10 people space. But I have trillion of these people. What do you do with those trillion people? You give them additional context. Sun and the moon and the Earth distance could be calculated 10 years back, right? But now with latest telescopes, you have the best, most updated data, right? For example, another example is 2 years back, if you asked me how many moons Jupiter had, it could be like 55. Today, we have so much bigger telescope and research, it is 58. So we added 2 more moons, right? The LLMs, when we trained it, it only knew 56 Jupiter moons. So when it told you guys information, it said 56. But that is incorrect in today's time. So how do you make LLMs more grounded to information? Those trillion parameters you have, you just pass information to it. Additional real-time information. You make the model search the latest data of distance of the moon or Jupiter's sizes or Jupiter's moon, and you feed it with the question this guy asked, what how many moons does Jupiter have? Right? This way LLM not only have its own understanding but additional real-time data. And that's what RAG is. Now, my database folks, what do you think? What kind of database I can have which I can connect to an LLM model? And you remember, every time I search, it needs to be fast, right? Because every time you type how many moons of Jupiter have, it needs to be quick. So, what are the database you think I can use which are fast? Anyone? What would you guys use? Like, think about if you have an LLM model, what kind of database you guys can connect to it, so you can pass additional information to it. Make a wild guess. SQL, NoSQL, MongoDB, um, an object, any cone. There's so many databases in the world. Have you guys heard about NoSQL and SQL, right?
We did 3 lectures on that SQL, so hopefully they remember.
Perfect. You guys remember NoSQL, right? What is that one thing NoSQL was invented for? Speed. NoSQL is that guy in the movie Car where it just like flash. That's what NoSQL is. It's fast. Now NoSQL, we can connect to an LLM model. So every time I search how many moons Jupiter have, I also search for NoSQL. Tell me how many moons Jupiter has, and it just gives you like 10 different articles. You take that information with that question and you give to the LLM models like, hey, this is the latest real-time information. This is the question of the customer. Based on your foundation model, figure out what the answer is, right? NoSQL can work really fine. But you know what really works well with this? NoSQL had one problem. It's not semantic. NoSQL's, the whole privilege of NoSQL is it just indexes, right? But those indexes, you can't predict those indexes really well with keywords like Jupiter, Moon. You can't just store that information, right? So what does Google does? You vectorize it. You vectorize those information into numbers and then make like a semantic search on it. Really fast, really good for your searching for word scenarios, and it's really fast for number calculations. And I think Kevin will cover like a lot of things here.
Yeah.
But I'll give you another example of RAG. I don't know if you guys know about this. Okay, what is the capital of India? Does anyone know it? New Delhi? That's amazing. Okay, how many of you guys did not know about it? Cool, right? You? Did you know? Are you genius right there? Okay, anyone who did not know, if I ask you now, what is the capital of India? What would you say now? New Delhi, right? Because you now heard that it was New Delhi. So, imagine it like this. LLM are like you guys. If you don't know that information, right? I have to tell you guys one time, and then you guys can learn from it. But our human brain is so fast, it can really rewire its neurons really fast. But LLMs are like slow to train. It takes sometimes 6 months to train your information. So I can't be just like, hey, let's retrain my whole $1 trillion parameter to just say India's capital is New Delhi. That's where RAG comes in. RAG gives you the latest information, so you don't have to train your foundation model. You just attach RAG with an LLM and ask LLM every time I give you a query, always search my RAG for real-time information. Now, how to build it? Madhav, what a lovely way to solve this problem just for the capital of India. But again, this helps a lot. Imagine you are working in a corporation like Microsoft or Amazon. You have internal documents which you can't do public, right? And you want, just like University of Washington information, like you have a syllabus. Those syllabuses are not online. Imagine those are private. Would you, from your eye, go to every single PDF and say, like, okay, where is this lecture? What they're going to teach you? Imagine you can just put everything into an LLM. But if you do it openly, anyone can take a look at that information, right? So RAG is also your encrypted layer to keep your information. So you can use a public LLM and give this LLM your private RAG. It will never spill out information to public. It will still process information on your private data. RAG can be used to build up applications. And billion-dollar applications work on this one. $1 billion. Now, how does it work? I want you guys to take your data set, right? Store it into a database, but the way you store it is going to be you vectorize them, right? What vectorizing is, it's very simple. You take images, audio, video, text, you transform them into embeddings. Embeddings are nothing but these matrices of numbers, -2, -1, 0, 1. When you see this lines -2, -1, 0, 1, this is nothing but the word ice cream. But in the embedding, we just converted the word ice cream into a number. Now these numbers, there are certain rules how you embed data. If it is man, woman, species, they all come under an umbrella of numbers. A simple set of different numbers. If you say non-living things like this cardboard, this wood, this panel, this door, this all come under a different bracket of vectors. And this all can be done by latest embedding models. They have these rules set already defined, universal. right? So you use these models, you vectorize these images, audios into numbers, and then, my friends, you can search rather than searching, let's say, rather than searching ice cream and going into a database, finding out in SQL where is this ice cream word. You run that select. This table contains ice cream. It is so slow on a billion documents. It's like big data, right? It's going to be so slow. You can't have LLMs waiting for that time. You vectorize them into numbers. Ice cream number is going to be -201. You store it as indices in your NoSQL databases, and then anytime I search in LLM that hey, what is ice cream, you take that query, also convert it into numbers, and then search those numbers into the vector database. Now you just have number comparing to numbers way faster than searching for a word in the database. Now you have indexes already figured out by just converting the query into numbers and then also storing the data into numbers. And fun fact, you know why NVIDIA stocks are up? You wanna know why? Because this thing you can't calculate on CPUs. CPUs are super slow multiplying vectors, multiplying matrix. You remember those matrix calculations you guys have? 1, 2, 3, 1, 2, 3 multiplied by just like 1:1, 1 to 3. You remember those like columns of matrix we had to calculate in like 7th grade? That thing is super hard on CPUs. And GPUs can solve it in like instant because those are parallel processing those matrix calculation. That's this is the reason NVIDIA stocks are so high. Because you need GPUs to calculate this, to calculate neural network, to calculate weight, to train them. It's all matrix calculations. That's the reason we buy those stocks because engineers knew this is I need GPUs for this. So you take this information, you store it, and then you have the whole vector database built on numbers. You give this API to your LLMs. So anytime anyone searches anything into your LLMs, you also go to your vector database, retrieve documents, and go back to your LLM and say that, okay, whatever the customer query was, also take this additional information with it. And now go and search in your LLM neural network to figure out what the answer could be, right? And this is where the RAG comes into picture. Now, I'm gonna show you a real use case for RAG, right? Query research paper instantly, find connection across studies, summarize literature reviews, generate citations and inferences. Because what happened for me was I don't have a RAG. I asked GPT-3 back in time, create a research paper, it hallucinated citations. Now every single model you use, it will say something like grounded by search or grounded by web information. They made the whole internet as a RAG for LLM models to now be more grounded, right? And I'm going to show you guys how to build this in like 5 minutes. I'll show you guys how to host your own LLM models, connect your own RAG to it, and make $1 billion, and then give Madhav 10% of it. We'll we'll all see this, because my job here is to get you guys more excited about this. Now I created this like quick demo for you of RAG, but this is the first time I'm using it. I've never used it before, so it could fail, right? So I do apologize for it. And I made this like 1 hour back. Oh, can I not see the screen? Okay, hold on. And show. Okay. Then go back to Edge. All right, start interactive demos. Okay. Wife, who is a cat, convert this text into numbers. I used an existing LLM model to do it, but you can use any model. You can use Gemini, you can use ChatGPT. Azure have its own text embedding models, which are very cheap to use. Some of them are even free to use. So these things are like very cheap. What did I get? 0.82 minus 0.45, 0.91. This number is unfathomable. I do not know what it is. But if you reverse the process, I will get from this number, wife, who is a cat, right? Embedding. This is RAG. Now, let's go to the playground. Let's add some words. Cat. Add. That's very slow, but I hope that it can give you some understanding. So this is your vector space. Usually vector spaces are 3D, but our brain works better in 2D, so I'm going to project everything in 2D. all these numbers are like points in a 3D graph. 0.82, you put a pointer there. 0.7, you put a pointer there. Next, when I type a query here, those things will be converted into numbers, and then we compare number with number, right? So dog and cat lives in this umbrella. Wife who is a cat, wife is over here. These are all 3D projected data. Now let's write a word. Let's say cat. When I click on search, you will see the cat now will be converted into numbers, and then we'll see the ranking. 98.8% match, wife who is a cat. This is a document I can pass to LLM. What is the second also document I can pass to? A title cat, CAT, 94.5. Now you saw what happened here. It did not tell this cat has a higher ranking than wife who is a cat. If it was just a match to match, this would have been 100%. But sometimes in semantic searches, a different document can have a higher rank for the same word, because it's probability of how the rich that data is. In this case, wife who is a cat has a higher percentage, but they're very close. You can search for dog, or you can search. I'm going to show you guys something different. I'm going to search for love. Now, love is a keyword I have not fed to the RAG. What do you think happens now? Just make a wild guess? What happens if I search love here? In the data set, there is nothing love, right? You have dog, cat, wife who is a cat, and wife. So the power of vector searches are, it will still give you results. It will give you results for those umbrella. Wherever that query lands up, what is the closest umbrella of data, closest vectors I can connect to, right? So let's search for it. Okay, query love. The first thing came up was why it's alive, in my opinion. But again, whatever. All right, 53.8% wife, 41.5% cat. Mother, how did that happen? How did love suddenly match with wife? Because those embedding models we used have certain rules. Then when we store those numbers are there in their umbrella. So whenever I search something like love, when it converted into numbers, those numbers were way closer to wife vectors than dog or something like that, right? That's how the vector search happens. That's the reason it's so powerful. Even though you have not exact words to the document, I will still give you documents which are more relevant. Is this not Google search? Exactly like Google search. I just gave you guys a way to build Google search, but for LLMs. Okay, I hope you guys like this demo. All right. Going back to our class, presenter view. Okay, was that fun? Do you guys learn that demo, right? All good? Any questions on that? And you guys will learn more about it in Kevin's class, because he's going to teach you guys exactly how everything is built. Now, future of AI, Madhav. How much time do I have, Kevin?
Whatever.
Okay.
You're fine. I can adjust my lecture to.
Cool. I'll take like 10 minutes. In 5 minutes, we'll teach how to go to Azure and build your own LLM, because I want you guys to take some more practical knowledge out of this. And then I'll tell you guys some hacks on prompt engineering. Okay? So we have learned so far RAGs, LLMs, neural networks. We learned when it was invented. We learned why it was invented. We created our own neural network right here, cat and dog. We learned what biases are. We learned what hallucinations are. And we learned how to beat hallucination by building our own RAG. Right? A lot of information we got from this lecture. Now, future of AI. Now, what is the future of AI? In 2 to 5 years, I can promise you that they will figure out a way to fix the problem of left hand writing. Because now there is more reasoning in LLMs. They just don't spurn out information, they also process them one more time to figure out if they are doing the right thing. Now, in future, you will have better reasoning capabilities, you will have multimodal AI, you will have AI agent that can take actions. I would be an agent working for Kevin, because everyone, because these AI agents are the next best thing. Imagine you take an LLM, you give its instructions that, hey, your job is to be a great software engineer, right? So what it will do is anything a software engineer can do, it will try to do it. Probably not as good as a normal engineer, but it will still try to do 50 to 60% of the job a software engineer can do. And that's a great thing for us because now you have more time to figure out what other problems I can solve, right? So it's always, these things are always better for humanity. We never questioned when calculator came up. A lot of people questions like, hey, the mental mathematics which people used to borrow, because there were people who used to get hired to do mental maths. Their jobs were like in chains that time when calculators came out. And everyone was like, hey, calculator is an abomination. Look what we did with calculators. We put a man on the moon with it. So do not think AI or agents or LLMs can take anyone's job. It just enhances the way we live. You're gonna have personal AI assistants. Siri will finally be good, right? And then in the next 10 years, you have AGI, which is the holy grail of models. AGI, right now you go to ChatGPT and you write stuff, and it gives you information. AGI, you don't need to write stuff. AGI just knocks on your door, is like, hey, Madhav, you need that. You need tickets to this concert, and the AGI can knock on my door and some days be like, hey, your wife is not happy. Go take her to Paris. This is what AGI is. It thinks for itself. Before I can ask a question, it knows the answer to. AGI will basically autonomous everything we know. And that's what we're trying to go and fight for. We need to figure out how to build this thing, which not only recognize patterns, but build its own intelligence. So this is where a lot of effort is going in right now. Now, before we start with this art of prompt engineering, I want you guys to know about RAG before I move away from this. So really gonna go and show you guys a quick small demo. Do you guys wanna know how to build, or do you guys already aware of this? Do you guys know how to take your, like, how to build your own LLMs and then connect a RAG to it and build a product out of it? Do you guys wanna see a 5-minute demo of it? Okay, I'll show you guys a quick thing.